Alright, on this problem, I probably would choose x and y intercepts to graph this one because it's in standard form. So I'm going to go ahead and do that and see if that works out for me. So my x-intercept is when I keep the x portion and I plug 0 in for y. So that gives me 6x less than 12. Divide by 6 on both sides and I get x is less than 2. So my x-intercept is 2. And my y-intercept is plug in 0 for my x value and solve. This goes away. 8y is less than 12. Now this is going to give me a fraction answer here, so I'll just convert that. This goes in there one time with 4 left over, so I get 1 and 4/8, which is 1 and 1/2. So my y value is 1 and 1/2, which would be right here. I'd be using a dotted line because it says less than. Now I have to caution you on this. Now if you can't go by shading above the line and below the line if it's not in y equals mx plus b form. If it's in standard form, you have to try a point. So if you're going to use x and y intercepts, you just have to try a point. You can't just go with above the line and below the line. It all has to do with the fact that if you're going to divide by a negative on both sides, that flips the sign. So what we're going to do is I'm going to pick a point right here, 4, 2, and I'm going to try it into the equation. 6x plus 8y is less than 12. So I'm going to put 4 in, and I'm going to put 2 in, and I'm going to see if it's a true statement. This is 24 plus 16 is less than 12. Well, when I add those together, I get 40. This is not true, so that means that this is not a part of the solution. So I'm actually going to be shading below the line on this one. If you want to just pick that you're going to shade above or below the line, then you always have to put it in y equals mx plus b form. Now this would just be as easy to pick your x and y intercepts, but I want to go ahead and solve for y so that you can see that you can always solve for y and put it in slope-intercept form. And if you do that, okay, then you can always look and see whether or not you're going to just shade above or below. The only time the sign's going to change is if you have that y as being negative. You can also remember that. So I'm going to go down one to the right one, down one to the right one, down one to the right one. This is my negative slope. You can see it's negative because it's going down. I need a solid line because it says less than or equal to, so I'll use a solid line. It's less than, since I have my y equation, solve for y, I should say, that I could just shade below the line because that will work as long as it's a y, the y is by itself. Next problem, you could use x and y intercepts again, but that's going to give me a nasty fraction. So I am going to go ahead and solve for y on this problem. Give me good practice on that. So I'll subtract 4x on both sides. Negative 3y is greater than or equal to negative 4x plus 9. I'm going to divide by a negative 3 everywhere. There's where I'm going to be flipping that sign around. So y, instead of greater than or equal to, is less than or equal to. Negative over negative is a positive 3/4 x plus a negative 3. I'm going to plot my negative 3. I'm going to rise 4, 1, 2, 3, 4, run 3. Rise 4, run 3. Or I could go down 4 to the left 3. I would have a solid line because it says less than or equal to, and I'll be shading below the graph. Because the y is by itself, I can just look at how I would be shading, and this is below the line. This next one is the y equals equation. What that means is that x is always 0. It doesn't matter what y is, but x is always 0. So I have 0, 1, 0, 2, 0, 3. It's a dotted line. This time, since it's not above or below, it's right or left. Where is x greater than 0? Well, that would be on this side. So I would be shading to the right-hand side because all